Hi everyone, so we are continuing today with composite functions. Now the word composite means made up of several different parts. So before we would see a regular function, f of 3, g of 4, h of 7, and that would be one function performed on a value. A composite function now is where you have multiple functions in your question. And just to start off, we have our little definition. A composite function is created when one function is substituted or placed into another function. Now, this would all make sense once we go into the example. In our example, we have two functions defined. We have f of x, which stands for 2x plus 1. So every value that takes the place of x is multiplied by 2 and then added to 1. Whereas we have g of x, which is equal to x squared plus 3. So every value that takes the place of x will be squared and then added to 3. Here we have to evaluate the composite function fg of 2. So we have function f, we have function g, and 2 is placed into what will end up being both of these functions. So to start our sum off, we are going to start with the number 2, and we're going to place it into the function that is closer to the value of 2. And reading this again, it's fg of 2. G is actually closer to 2. So we have to place 2 into the g function. And then when we get our result, then we are going to place that into the other function, which is the f function. So we're going to start with g of x, the function closer to your value. G of x is equal to x squared plus 3. And we're going to find g of 2. So where we have x, we're going to replace it with the number 2. So that will be 2 squared plus 3. 2 squared is equal to 4. And 4 plus 3 gives us 7. So we've found g of 2, and that's equal to 7. We're now going to take this part of our result, g of 2 equals 7, and we're going to place it into the outer function, the f function. So f of x is equal to 2x plus 1. And fg of 2, we're going to obtain by putting 7, which is our g of 2, into the f function. So everywhere we have x, we're going to replace it with the number 7. So 2x, that's 2 by 7, add 1, and 2 7s are equal to 14. So that's 14 plus 1. Fg of 2 is equal to 15. So essentially, to obtain fg of 2, we put our value into the function closer to it, which was g, obtained that value, and then placed it into our second function, the f function. So we're going to look at another example. We're using the same two functions, f of x and g of x. We're going to find something else. We're going to find gf of 2. Now, this is different from fg of 2 because the function f now is written closer to the value. So we're going to actually start with the f function, and we're going to place the same value of 2 into it. So our first function is f of x. That's what we're writing down first. F of x is equal to 2x plus 1. And we're going to find f of 2. So everywhere we have x, we're replacing it with the number 2. So that's 2 by 2 for 2x plus 1. 2 2s are 4. 4 plus 1 gives us 5. F of 2 works out to be 5. We found the value when we put our value into the function closer to it, and that would have been f of 2, which worked out to be 5. We're now going to go to the second function, which is a g of x function. G of x is equal to x squared plus 3. And we're going to take our result, our f of 2, and place that into the g function to get gf of 2. So everywhere we have x, we're going to replace it with f of 2, which is equal to 5. So instead of x squared, that's 5 squared plus 3. 5 squared is 25. And 25 plus 3 gives us 28. So once again, to obtain g f of 2, we took the 2 and placed it into the function which is written closer to the value. 2 went into the f function. So f of 2 was first obtained, which worked out to be 5, and then that 5 was placed into the second function, the one further away from the value, or the g function.